So what we have basically is if you push one of the three buttons, you'll lock or turn a binary bit on for recognition of which bit or which button was pushed. Also, we can home the station with pushing all three buttons at the same time. The homing sequence operates if you hold the three buttons for 3 seconds based on this timer. Okay, the track that moves the cup is called motor run right and motor run left. Basically, we've got all the actions in here that make the motor run in one direction or the other. As you know, you can only use an output once, so all of the information that tells that motor to run in one direction or the other has to be put within the same run. We then have the hopper motors that run. So basically, once they're in position, once the proc sensors are made for that position, the hopper motors will come on and they'll stay on for a certain time, which is set by a timer. There's also a move delay, so everything stops before the cup moves again. Okay, we have a flavor complete bit, so we use that to control some of the activities on down in the cycle itself. And we have a motor up and motor down, which takes the mixing motor platform up and down. Again, you can only have one output, so the actions that make that go up or down all have to be within the same rungs. We have a water pump, so it's activated by certain activities, and then it stays on for a certain amount of time. We're choosing 8 seconds based on the timer. We get a water complete bit. Again, I'm using a lot of binary bits to lock positions and allow me to know exactly where I am to issue additional sequential commands. Then we have a mix motor itself, so basically it comes on once the water cycle is complete. It stays on with a timer, which again is set at 8 seconds. And then we'll have a mix complete. Once mix is complete, the station will bring the cup back to the home position.
By looking at the design, we can say that the first material we used was the aluminum strut that we cut with the vertical bend. So it's amazingly surprised that we cut everything within a range of 1 millimeter of the measurements. It is also true that we did some machining on the parts. As we can see here, we make some axles for the process here in the product. We machined these axles and where the belt sits on, and also for the elevator mechanisms that we can see here. We also make some holes for the bearing where the axles actually sits on, by doing some press fits on the measurements. On the other hand, we can say that the project has also 3D printed parts that we make on the Creo. The hoppers as well as the wheels are also 3D printed for this project. On the other hand, we also have 3D printed designed holders for the elevator mechanism, as well finally for the cup holder. On the other hand, we also 3D print the mixing bar as well as the proximity switch holders that we have here in the design. Also, we can see that we have a proximity switch on the cup holder. So from the wiring perspective, we can say that all the proximity switches are wired in, and that we have some three different push buttons that gives it 3 different positions or 3 different flavors on the machine.
Want grape? We have grape. Well, we did have grape until we just ran out. Mix. And there you go. Super great.
Asu, parece comercial.
That tastes pretty good right there. So all of the wiring, basically everything's using the Micrologix 1000, and we're using another external power supply. So the PLC itself is run off of power, but it only switches the switches on and off. All of the actual relays and the power to all the motors and to the pump actually go through the main power supply. We're running at about 12 volts, give or take.
While we were working on this project, we learned from each other on how to operate different machines. For instance, the lathe machine and the milling machine. We also upgraded our skills in the operations of the 3D printing machines. On the other hand, from the electric perspective, we learned how to connect every component to the PLC, specifically the relays, in which we had more problems to wire them to the prototype. In order to finish this drink dispenser, we used the knowledge obtained in the class of the CNC machine, 3D printing, and the programming of the PLC by using the software RS Logix 5000 to develop our ladder logic. This project was chosen because it fulfills all the requirements needed. Even though we didn't put a visual CNC requirement, we already have the G-code engraving of UTRGV Camp Spring 2018 to do it in the future. By looking at the results obtained, we determined this project was successful.